Scientists may have found an answer to the mystery of dark matter. It involves an unexpected byproduct. For about 50 years, the scientific community has been grappling with a substantial problem. There isn't enough visible matter in the universe. All the matter we can see, stars, planets, cosmic dust, and everything in between, can't account for why the universe behaves as it does. And there must be 5 times as much of it around for researchers' observations to make sense, according to NASA. Scientists call that dark matter because it does not interact with light and is invisible. In the 1970s, American astronomers Vera Rubin and W. Kent Ford confirmed dark matter's existence by looking at stars orbiting at the edge of spiral galaxies. They noted that these stars were moving too fast to be held together by the galaxy's visible matter and its gravity. They should have been flying apart instead. The only explanation was a large quantity of unseen matter, binding the galaxy together. What you see in a spiral galaxy, Rubin said at the time, is not what you get. Her work built upon a hypothesis formulated in the 1930s by Swiss astronomer Fritz Zwicky and kick-started a search for the elusive substance. Since then, scientists have been trying to observe dark matter directly and even built large devices to detect it, but so far with no luck. Early in the search, renowned British physicist Stephen Hawking postulated that dark matter could be hiding in black holes, the main subject of his work, formed during the Big Bang. Now, a new study by researchers with the Massachusetts Institute of Technology has brought the theory back into the spotlight, revealing what these primordial black holes were made of and potentially discovering an entirely new type of exotic black hole in the process. It was really a wonderful surprise that way, said David Kaiser, one of the authors of the study. We were making use of Stephen Hawking's famous calculations about black holes, especially his important result about the radiation that black holes emit. Kaiser said, "These exotic black holes emerge from trying to address the dark matter problem. They are a byproduct of explaining dark matter. The first quintillionth of a second, scientists have made many guesses for what dark matter could be, ranging from unknown particles to extra dimensions. But Hawking's black holes theory has only lately come into play. People didn't really take it seriously until maybe 10 years ago," said study co-author Elba Alonso Monsalve, an MIT graduate student. And that's because black holes once seemed really elusive. In the early 20th century, people thought they were just a mathematical fun fact, nothing physical. We now know that nearly every galaxy has a black hole at its center, and a researcher's discovery of Einstein's gravitational waves, created by colliding black holes in 2015, a landmark finding, made it clear that they are everywhere. Actually, the universe is teeming with black holes, Alonso Monsalve said, but the dark matter particle has not been found, even though people looked in all the places where they expected to find it. This is not to say dark matter is not a particle, or that it's for sure black holes. It could be a combination of both. But now, black holes as candidates for dark matter are taken much more seriously. Other recent studies have confirmed the validity of Hawking's hypothesis, but the work of Alonso Monsalve and Kaiser, a professor of physics and the Germeshausen Professor of the History of Science at MIT, goes one step further and looks into exactly what happened when primordial black holes first formed. The study, published June 6th in the journal Physical Review Letters, reveals that these black holes must have appeared in the first quintillionth of a second of the Big Bang. That is really early, and a lot earlier than the moment when protons and neutrons, the particles everything is made of, were formed, Alonso Monsalve said. In our everyday world, we cannot find protons and neutrons broken apart, she added, and they act as elementary particles. However, we know they are not, because they are made up of even smaller particles called quarks, joined together by other particles called gluons. You cannot find quarks and gluons alone and free in the universe now, because it is too cold, Alonso Monsalve added. But early in the Big Bang, when it was very hot, they could be found alone and free. So the primordial black holes formed by absorbing free quarks and gluons. Such a formation would make them fundamentally different from the astrophysical black holes that scientists normally observe in the universe, which are the result of collapsing stars. Also, a primordial black hole would be much smaller, only the mass of an asteroid on average, condensed into the volume of a single atom. But if a sufficient number of these primordial black holes did not evaporate in the early Big Bang and survive to this day, they could account for all or most dark matter, a long-lasting signature. During the making of the primordial black holes, another type of previously unseen black hole must have formed as a kind of byproduct according to the study. These would have been even smaller, just the mass of a rhino. condensed into less than the volume of a single proton. These minuscule black holes, due to their small size, would have been able to pick up a rare and exotic property from the quark-gluon soup in which they formed, called a color charge. It is a state of charge that is exclusive to quarks and gluons, never found in ordinary objects, Kaiser said. This color charge would make them unique among black holes, which usually have no charge of any kind. It's inevitable that these even smaller black holes would have also formed as a byproduct of primordial black holes formation, Alonso Monsalve said, but they would not be around today anymore, as they would have evaporated already. However, if they were still around just 10 millionths of a second into the Big Bang, when protons and neutrons formed, they could have left observable signatures by altering the balance between the two particle types. The balance of how many protons and how many neutrons were made is very delicate, and depends on what other stuff existed in the universe at that time. If these black holes with color charge were still around, they could have shifted the balance between protons and neutrons in favor of one or the other, just enough that in the next few years we could measure that, she added. The measurement could come from Earth-based telescopes or sensitive instruments on orbiting satellites, Kaiser said, but there could be another way of confirming the existence of these exotic black holes, he added. Making a population of black holes is a very violent process that would send enormous ripples in the surrounding space-time. Those would get attenuated over cosmic history, but not to zero, Kaiser said. The next generation of gravitational detectors could catch a glimpse of the small mass black holes, an exotic state of matter that was an unexpected byproduct of the more mundane black holes that could explain dark matter today. Many forms of dark matter. What does this mean for the ongoing experiments that are trying to detect dark matter, such as the LZ dark matter experiment in South Dakota? The idea that there are exotic new particles remains an interesting hypothesis, Kaiser said. There are other kinds of large experiments, some of which are under construction, looking for fancy ways to detect gravitational waves, and those indeed might pick up some of the stray signals from the very violent formation process of primordial black holes. There's also the possibility that primordial black holes are just a fraction of the dark matter, Alonso Monsalve added. It doesn't really have to be all the same, she said. There are 5 times more dark matter than regular matter, and regular matter is formed from a whole host of different particles. So why should dark matter be a single type of object? Primordial black holes have regained popularity with the discovery of gravitational waves, yet not much is known about their formation, according to Nico Capilouti, an assistant professor in the physics department of the University of Miami. He was not involved with the study. This work is an interesting, viable option for explaining the elusive dark matter, Capilouti said. The study is exciting and proposes a novel mechanism of formation for the first generation of black holes, said Priyamvada Natarajan, the Joseph S. and Sophia S. Fruton Professor of Astronomy and Physics at Yale University. She was also not involved with the study. All the hydrogen and helium that we have in our universe today was created in the first 3 minutes, and if enough of these primordial black holes were around until then, they would have impacted that process and those effects may be detectable, Natarajan said. The fact that this is an observationally testable hypothesis is what I find really thrilling, aside from the fact that this suggests nature likely makes black holes starting from the earliest times through multiple pathways. Thanks for watching. Please subscribe on the channel and like the videos. Thank you.